Welcome to Algebra Online. Today I'm discussing inverse functions, which are notated as f to the negative 1 x. What is an inverse function? It simply means that if you take a function, I'm going to say f, and you put in some value, it could be 0, 1, 5, 10, whatever. I'm going to call it x because it's some unknown value. You're going to get out an output of y. This is some other value. An inverse function simply says that if you were to switch these two and put y as the input, as your output, if you get x, then that means an inverse function exists. There are three ways teachers like to test this topic. One is with coordinate problems, another is with simple equations that you have to solve with some algebra, and then the last thing is with graphing problems. So let's look at a few different types. So this is a coordinate problem. A function f of x has the following coordinates. What are the coordinates of the inverse function of x? All you have to do is swap your x values with your y values and your y values with your x values in each ordered pair. So negative 1, 3, 4, 2, 8, negative 6. All you do is swap the x and the y. And that's it. That's the answer. Pretty simple, so let's move on. Now this is an equation type of problem. So given f of x equals 3x minus 2, find the inverse. First you're going to replace f of x with y, and then you just keep the rest of the equation the same. And then in your second step you're going to replace your x's with your y's and your y's with your x's. Now in this example I only have one of each, so it's pretty simple. X equals 3y minus 2. Now you want to solve for y and get y by itself. So I'm going to add 2 to both sides, because what you do to the one side you have to do to the other. And to get y by itself at this point I just need to divide by 3. So y equals x plus 2 over 3, which equals the inverse. Now, sometimes teachers will ask you to prove that this is truly the inverse of the original function. There exists a rule that says if you take the inverse function and replace it for x in the original function, you should get x as your answer. And that is written in some confusing lingo like this. So let's see what that actually means, because I think it's kind of hard to tell. What it means is you're going to take this function here, 3 times x minus 2, and you're going to replace the x with this new function down here. So 3 times x plus 2 over 3 minus 2. Well, 3's cancel out, right? So I'm left with x plus 2 minus 2. And then the 2's cancel out because that becomes 0. And all I'm left with is x. So there you have it. This is in fact the inverse function of the original equation. Let's do another example. So again, our first step is to put y equals square root x minus 3. Now I need to swap the x's and the y's. So x equals square root y minus 3. Now let's do a little algebra and get rid of this square root. We're just going to square this, and what we do to the left we do to the right. So now I have x squared equals y minus 3, and I want to get y by itself, so I'm just going to add the 3 to each side, and I'm left with x squared plus 3 as my inverse function. Let's go ahead and prove that that is in fact correct. So my original function is x minus 3 under square root. I'm going to replace x with the inverse function from down here. So now I have x squared plus 3 minus 3. Remember, I have to keep the minus 3 from the original function above. And now I just have square root of x squared because the 3 minus 3 becomes 0, and that equals x. So that is in fact the inverse function. Alright, so here's some graphing questions. The first one might be determine whether the function is a one-to-one function. Why does this matter? This matters because you cannot have an inverse function unless the original function, f of x, was a one-to-one function. All that means is you're going to use something called the horizontal line test. You take your pencil and draw horizontal lines through the graph. And as long as the line only goes through one point in every little place, then it is a one-to-one function. So let's move on to the middle graph, which is x squared, happens to be the graph, in case you notice that. Well, I can see right away I have a problem, right? Because if I run a horizontal line across, it's hitting two spots. Same thing right here and right here, right? That would be a problem, that would be a problem, this would be a problem. So this one is not a one-to-one function. And because it's not a one-to-one function, it also does not have an inverse. So that might be a question you would say is, determine whether these graphs are one-to-one functions, or determine whether these functions have an inverse function. So in this case, in this middle one here, x squared is in fact a function, but it does not pass the horizontal line test, so it does not have an inverse function. Alright, now let's look at the third graph. Well, it's okay here and here and here, and it's also okay here and here and here and here and here and here. But we've got a huge problem right here. Ding, 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 ding. That's a problem. All of these points on here, that can't be in a one-to-one function. So this is not one-to-one, and it also does not have an inverse function. Not possible. And let's think about this. Why is that? It's because when you have all of these values that could be possibilities along the same line, well, if I put in x for y or y for x, I don't know which value I'm going to get out because it could be one of any of these points. So hopefully that kind of clarifies that. And let's do another graphing question. So you might be given a graph like the one on the left, and it'll say, given this graph, graph the inverse function. Well, remember from that coordinate problem we had, you take your x's and y's in your original function and you just swap them to get the inverse. So first we have to figure out what our points are in the original graph. So this one would be an x value of 2 and a y value of 0. And this one would have an x value of 0 and a y value of -2. So if I want to find the inverse function, all I have to do is swap those. Remember, what was x becomes y, what was y becomes x. And now I'm just going to graph these points. So 0, 2, and -2, 0. And those are enough points for me to connect the dots, almost, to just make that point bigger, and that would be the answer. Alright, so another problem you might come across is, it'll say, given f of 2 equals 7, find the inverse at 7. All you have to do when you see problems like this is just pick an answer that is the number that you aren't seeing from the original. So here I'm seeing 7. I've got 7 already, so the answer has to be the other number. It's got to be 2. So let's see, what do you think this would be? We've already got -1, -1, so what's the answer to this? Well, it's got to be 3. That's your answer. I hope this helped, and if so, please feel free to like the video. I appreciate any likes, and feel free to subscribe or request additional topics. Thanks, and have a good day.